Somewhere far away, past Saturn's beautiful rings, there's a moon that should not exist. It does not look round like other moons. It looks broken. It looks eaten. Scientists call it a sponge, but this sponge is bigger than many countries on Earth. Its name is Hyperion. When the first clear pictures came back from space, even trained scientists went silent. Nobody expected a moon like this. Nobody could explain why it looked this way. And here is the strangest part. This moon does not spin like normal moons. It tumbles. It flips. Nobody on Earth can predict which way it will face tomorrow. So what happened to Hyperion? Was it hit by something massive? Is it hollow inside? Or is there something we still do not understand about how moons are born? Stay with us till the end of this video, because part 4 will show you the theory that even NASA scientists find hard to believe. But before we go further, if you love space mysteries like this, hit that subscribe button right now and turn on the bell icon. We bring you a new space mystery every week, and you do not want to miss what's coming next. Now, let's begin the story of the weirdest moon in our solar system. Far away in our solar system, past the beautiful rings of Saturn, there's a small world that most people have never heard of. It is not a planet. It is not a star. It is a moon. But this moon is not like any other moon we know. Its name is Hyperion, and its story begins almost 200 years ago, on a quiet night when a man looked up at the sky and noticed something strange. The year was 1848. Telescopes at that time were not powerful like the ones we have today. They were simple tools, made of glass and metal, built by hand. Yet even with these basic tools, astronomers were slowly mapping out the solar system, one object at a time. Saturn was already famous for its rings. People had been watching those rings for many years. But few people were looking closely at the tiny points of light moving around the planet. One of those points of light caught the attention of two astronomers. Their names were William Cranch Bond and his son George Bond, working from an observatory in the United States. At almost the same time, on the other side of the world, a British astronomer named William Lassell was looking at the same tiny light. All three men, working separately, noticed something new near Saturn. It was small, it was faint, but it was moving in a way that told them it was not a star. It was a moon. They named this new moon Hyperion, after one of the Titans in old Greek stories. In Greek mythology, Hyperion was a powerful being connected to light. It was a fitting name for a new discovery in the sky. But at the time, nobody knew just how strange this little moon would turn out to be. For many years after its discovery, Hyperion remained a mystery. Early telescopes could only show it as a small dot of light near Saturn. Astronomers could calculate its orbit. They could measure roughly how far it was from Saturn. They could estimate how long it took to complete one trip around the planet. But they could not see its shape. They could not see its surface. To the human eye, and even to the best telescopes of that century, Hyperion was just a point of light, one among many objects circling the ringed planet. This went on for over 100 years. Generations of astronomers studied the sky, wrote papers, and passed down their knowledge. But Hyperion stayed hidden behind its own distance. It orbited quietly, far from Earth, keeping its secrets safe. Nobody could have guessed that this small, faint moon was hiding one of the strangest shapes ever found in our solar system. Everything began to change in the 20th century when humans finally found a way to leave Earth and explore space directly. Instead of only looking through telescopes from the ground, scientists built machines that could travel through space itself and take pictures up close. These machines were called space probes, and they would change everything we knew about the solar system, including what we knew about Hyperion. The first real breakthrough came from NASA's Voyager missions. In the late 1970s and early 1980s, two spacecraft named Voyager 1 and Voyager 2 were launched from Earth. Their job was to travel through the outer solar system and photograph the giant planets and their moons. This was one of the most ambitious space missions ever attempted. As Voyager 2 passed by Saturn in 1981, it captured images of many of Saturn's moons, including a distant, blurry picture of Hyperion. For the first time in human history, people could see that Hyperion was not just a plain, round moon like Earth's own moon. The pictures were not perfectly clear, but they showed something unusual. Hyperion did not look smooth. Its surface seemed rough, uneven, almost broken in appearance. Scientists were intrigued, but the Voyager images were still too distant and too blurry to reveal the full picture. The true shock was still waiting, years into the future. That moment finally came with the Cassini mission. Cassini was a spacecraft launched by NASA in 1997, built specifically to study Saturn, its rings, and its many moons in incredible detail. After a journey of 7 years through space, Cassini arrived at Saturn in 2004 and began one of the most detailed studies of the planet ever conducted. Over the years that followed, Cassini flew close to many of Saturn's moons, taking sharp, clear photographs that scientists back on Earth had never seen before. In September 2005, Cassini flew close enough to Hyperion to finally capture clear, detailed images of its surface. And when those pictures arrived back on Earth, scientists were stunned. This was not simply an oddly shaped moon. This was something almost impossible to believe. Hyperion looked like a giant gray sponge floating silently in space. Its entire surface was covered in deep, dark craters, packed closely together, almost touching one another. Between the craters were strange, sharp ridges, giving the whole moon a rough, jagged texture, unlike anything seen on other moons. Most moons in our solar system, even ones covered in craters, still have areas of smooth, flat ground. Hyperion had almost none of that. Nearly its entire visible surface was made up of these strange, deep pits. Scientists who had studied space objects for their entire careers had never seen anything quite like it. Normal moons, even heavily cratered ones like our own moon or Mercury, still have some smooth regions. Hyperion looked almost entirely broken, almost entirely hollow in appearance, like a piece of styrofoam that had been struck repeatedly by tiny impacts over and over again for billions of years. The images spread quickly among astronomers around the world. Many could hardly believe what they were looking at. It was one thing to imagine a strange-looking moon. It was another thing to actually see one, up close in stunning detail, floating quietly around Saturn as it had done for billions of years, unseen by human eyes until now. This discovery changed how scientists thought about moons in our solar system. Up until then, most people imagined moons as simple, solid, round objects circling their planets. Hyperion showed that this was not always true. Some moons could be strange, uneven, and full of unanswered questions. It challenged old assumptions and opened the door to new ones. But the story of Hyperion was only just beginning. The pictures from Cassini answered one question. What does Hyperion actually look like? While opening up many more. Why did it look this way? Why were there so many craters packed so closely together? Why did its surface never seem to fill in with dust, unlike other cratered moons? And perhaps most puzzling of all, why was this moon so unusually light for its size, almost as if it were partly hollow inside? These questions would lead scientists even deeper into the mystery of Hyperion, revealing details about this small moon that would seem almost too strange to be real. But that discovery of the mystery of the sponge is where our story goes next. For now, remember this. In 1848, 3 astronomers looked into the night sky and found a small, faint light near Saturn. They had no way of knowing that this tiny discovery would one day reveal one of the strangest, most puzzling objects in our entire solar system. It took over 150 years, and machines built by human hands traveling millions of miles through space just to finally see Hyperion's true face. And once we saw it, we realized we had only begun to understand it. When the Cassini spacecraft sent back its first clear pictures of Hyperion, scientists on Earth stared at their screens in silence. What they saw did not look like a moon at all. It looked like something pulled out of the ocean. It looked like a giant gray sponge floating quietly in the darkness of space, circling Saturn as it had done for billions of years. At first glance, this might sound like a simple comparison, just a fun way to describe something strange. But the more scientists studied Hyperion, the more they realized this comparison was not just clever, it was almost scientifically accurate. Hyperion truly behaves like a sponge, in ways that go far deeper than its appearance. To understand why, we first need to understand what makes Hyperion's surface look so unusual. Nearly every part of Hyperion is covered in deep, round craters. This alone is not surprising. Many moons in our solar system are covered in craters because moons do not have thick atmospheres to burn up small space rocks before they hit the surface. Every time a piece of rock or ice crashes into a moon, it leaves behind a crater, a small bowl-shaped scar on the surface. But on most moons, over long periods of time, these craters slowly fill in. Dust settles into them, small particles drift and collect, gradually smoothing out the sharp edges. This process is slow, but over millions or billions of years, it softens the surface, creating flatter, gentler landscapes in between the older craters. Hyperion does not follow this pattern. Its craters stay deep, sharp, and clearly defined, almost as if they were formed recently, even though many of them are extremely old. Between the craters, instead of smooth ground, there are strange sharp ridges, almost like the walls between the holes of a sponge. This gives the entire moon a rough, jagged, uneven texture, with barely any smooth areas at all. Scientists began asking an important question. Why doesn't Hyperion's surface fill in and smooth out like other moons? The answer to this question led them to an even bigger discovery about what Hyperion is made of. When scientists calculated Hyperion's mass and compared it to its size, they found something surprising. Hyperion is much lighter than it should be for an object of its size. If Hyperion were a solid, dense ball of rock and ice like many other moons, it would weigh far more than what scientists measured. Instead, its density turned out to be very low, roughly close to that of water ice, but even less packed together than expected. This low density gave scientists an important clue. It suggested that Hyperion is not a solid object all the way through. Instead, it likely contains a significant amount of empty space inside it, hidden gaps and pockets throughout its structure, almost like a moon made of holes and cracks rather than solid rock. This porous structure explains a lot about Hyperion's strange appearance. When a small space rock crashes into a solid, dense moon, The impact pushes material outward and downward, sometimes throwing debris that eventually settles back down and fills in the crater over time. But when something crashes into a surface as porous and empty as Hyperion's, the impact behaves very differently. Instead of pushing material outward evenly, much of the impact energy gets absorbed into the empty spaces within Hyperion's structure. Rather than creating debris that spreads out and eventually smooths the surface, the impact tends to compress the material downward and inward, punching a clean, deep hole rather than a wide, shallow crater. This is very similar to what happens when you press your finger into a real kitchen sponge. The material compresses inward around your finger rather than spreading outward the way solid material would. This is why scientists now often describe Hyperion's surface using the same word people use for describing impacts on foam or sponge material. The surface appears to crush rather than spread when struck. Over billions of years, countless small impacts have created the same effect across the entire moon, producing exactly the kind of deep, sharp-edged, closely packed craters seen in Cassini's pictures. There's another unusual detail that adds to this mystery. On most moons, when something is exposed to the harsh environment of space for a long time, it tends to become darker due to space weathering, a slow process caused by solar radiation and small particle impacts. But scientists studying Hyperion noticed something odd about the darker material collecting inside its deepest craters. The floors of many craters on Hyperion appear unusually dark, almost like they are coated in a strange reddish or blackish substance. Scientists believe this darker material may be made up of organic compounds, complex carbon-based substances, similar to some materials found on other icy bodies in the outer solar system. Nobody expected to find this kind of material sitting quietly at the bottom of Hyperion's deep, sponge-like craters. Some scientists believe that Hyperion's icy surface might be slowly evaporating in certain areas, a process called sublimation, where ice transforms directly from solid form into gas without ever becoming liquid. Over time, as this happens, the darker material left behind may become more visible, especially in shadowed, colder crater floors where ice lingers longer. This process could help explain the unusual, dark, patchy appearance seen in some of the deeper pits across Hyperion's surface. Taken together, all of this paints a picture of a moon unlike anything else studied up close before. Hyperion is not a solid, heavy world. Instead, it may be closer to a loosely packed collection of ice and rock, held together weakly, filled with empty spaces, covered in deep, sharp-edged craters that behave more like punctures in foam than typical impact craters. Its surface hides dark, mysterious material sitting quietly in its deepest pits, hinting at processes we still do not fully understand. This raises an important and unsettling question. If Hyperion truly is this loosely held together, this fragile, this full of empty space inside, how has it managed to survive for so long? Our solar system is not calm. Space rocks, dust, and debris are constantly moving, occasionally crashing into moons, planets, and other objects. A structure as fragile as scientists now believe Hyperion to be should, in theory, be extremely vulnerable to being broken apart by a large enough impact. And yet, here Hyperion is, still orbiting Saturn after billions of years, sponge-like and cratered, but still very much in one piece. This mystery does not have a simple answer, and it connects directly to an even stranger behavior that scientists discovered about Hyperion, something that makes this moon even more unusual than its sponge-like appearance already suggests. Because while Hyperion's surface tells one strange story, the way this moon actually moves through space tells an even stranger one. Unlike almost every other moon in our solar system, moons that spin steadily and predictably around their planets, Hyperion does something that no other major moon does. It tumbles. Not in a smooth, steady pattern, but in a chaotic, unpredictable way that has puzzled scientists for decades. And to understand why this happens and what it might mean for the future of this strange little world, we need to look closely at the way Hyperion moves. A mystery that reveals just how different this moon truly is from everything else we know in our solar system. Imagine standing on the surface of a moon, looking up at the sky, waiting for sunrise. On almost any other moon in our solar system, you could predict exactly where the sun would appear. You could calculate the exact time it would rise, and the exact direction it would come from. This is because most moons spin in a smooth, steady, predictable way. But if you were standing on Hyperion, none of that would be true. You would have no idea where the sun might appear next. It could rise from above you. It could appear from below. It could shift its position entirely from one day to the next, with no clear pattern at all. This is because Hyperion does something that almost no other major moon in our solar system does. It tumbles. To understand how strange this really is, we first need to understand how most moons normally behave. Take Earth's own moon, for example. It rotates in a very steady, predictable way, always showing the same face toward Earth. This happens because of a process called tidal locking, where the gravity of a larger body, like a planet, gradually slows down and stabilizes the rotation of a smaller object, like a moon, over a very long period of time. This same pattern happens with most large moons throughout our solar system. Over millions of years, the steady pull of gravity from their planet locks their rotation into a smooth, predictable rhythm. Even moons that are not perfectly tidally locked usually still spin in a fairly regular, consistent way, making their movement easy for scientists to calculate and predict far into the future. Hyperion breaks this pattern completely. When scientists began carefully tracking Hyperion's rotation using data from telescopes and later from the Voyager and Cassini spacecraft, they noticed something they had never seen before in a large moon. Hyperion's rotation was not steady, it was not predictable. Instead, it appeared to tumble chaotically through space, its orientation shifting unpredictably over time. This means that, unlike other moons, which spin around a fixed axis in a consistent direction, Hyperion's axis of rotation seems to wobble and shift constantly. Sometimes it spins faster. Sometimes it slows down. Sometimes its orientation flips in ways that are extremely difficult to calculate in advance. Scientists studying its movement realize that predicting Hyperion's exact orientation more than a few weeks into the future becomes almost impossible because tiny variations in its motion multiply over time, leading to wildly different outcomes. This kind of unpredictable motion has a special name in science. It is called chaotic rotation. The word chaotic here does not simply mean messy or random in an everyday sense. In science, chaotic behavior describes a system that is extremely sensitive to small changes, where even a tiny difference in starting conditions can lead to completely different results over time. Predicting the exact weather more than a couple of weeks in advance is difficult for a similar reason, because weather systems are also chaotic. Hyperion's rotation behaves in much the same unpredictable way, but instead of clouds and wind, it involves an entire moon tumbling slowly through space. So why does Hyperion behave this way when almost no other moon does? Scientists believe the answer comes down to a combination of two key factors: Hyperion's highly irregular shape and the strong gravitational influence of Saturn and its other large moons, particularly the massive moon Titan, which orbits nearby. Unlike round moons, which distribute gravity evenly around their surface because of their symmetrical shape, Hyperion's odd, elongated, uneven shape means that gravity does not pull on it evenly. Different parts of its irregular structure experience slightly different gravitational forces from Saturn as it moves along its orbit. Combined with the added gravitational pull from nearby Titan, these forces create a complex, unstable push and pull effect on Hyperion's rotation, preventing it from settling into a steady, predictable spin the way most other moons eventually do. In simple terms, Hyperion's strange, lumpy shape makes it far more sensitive to these outside gravitational forces than a smooth, round moon would be. Instead of gradually stabilizing into a fixed rotation like other moons, Hyperion remains locked in this ongoing, chaotic tumble, with no clear end in sight. This discovery fascinated scientists, not just because it was unusual, but because it gave them rare, real-world proof of chaotic motion happening on a massive scale in our own solar system. For a long time, chaotic systems were mostly studied through mathematics and small-scale experiments here on Earth. Hyperion gave scientists something incredibly rare: a giant, real physical object, hundreds of kilometers wide, actively demonstrating chaotic motion right in front of their instruments out in the depths of space. But beyond the science, there is something almost eerie about imagining what this would actually look like or feel like up close. A moon that does not know which way is up. A moon where day and night do not follow any fixed pattern. A moon that, if you watched it long enough from a spacecraft, would seem to slowly twist, flip, and tumble in ways that never quite repeat the same way twice. This unpredictable behavior also raises new questions for scientists thinking about future space missions. If humans or robotic landers were ever to attempt a landing on Hyperion, this chaotic tumbling would make the mission far more complicated than landing on a moon with steady, predictable rotation. Engineers would need to account for the fact that Hyperion's orientation could shift unexpectedly, making precise landing calculations significantly more difficult than missions to more predictable worlds. There is also a deeper mystery hidden inside this chaotic behavior, one that connects back to everything we learned about Hyperion's strange, sponge-like structure. Scientists now understand fairly well how Hyperion tumbles, thanks to the combined effects of its irregular shape and nearby gravitational forces. But understanding how it tumbles does not fully explain why Hyperion ended up with such an unusual, elongated, irregular shape in the first place. Most moons, especially ones large enough to have noticeable gravity of their own, tend to form into roughly round shapes over time, because gravity naturally pulls material inward evenly from all directions, smoothing out major irregularities as the moon forms. Hyperion, however, never fully settled into this rounded shape. Its structure remained lumpy, elongated, and irregular, defying this expected pattern. This leads scientists to a much bigger and more dramatic question, one that goes beyond simply explaining Hyperion's rotation or its sponge-like surface. What if Hyperion's strange shape is not simply the result of how it originally formed billions of years ago? What if, instead, something happened to Hyperion, some massive violent event in its ancient past, that left it broken, damaged, and forever changed from whatever shape it may have once had? This possibility opens the door to one of the most fascinating and debated theories in the entire story of Hyperion, a theory that suggests this strange little moon may actually be the shattered remains of something much larger, something that once existed peacefully in orbit around Saturn until a catastrophic event changed everything. And that theory, along with the biggest unanswered questions still surrounding Hyperion today, is where our story goes next. By now, Hyperion has already shown us that it breaks almost every rule we expect a moon to follow. It does not have a smooth, rounded shape like other moons. Its surface looks like a giant sponge covered in deep, sharp craters that never fill in. It is strangely light for its size, suggesting large, empty spaces hidden inside it. And instead of spinning steadily like almost every other moon in our solar system, it tumbles chaotically through space, unpredictable and unstable. All of these strange features lead scientists back to one central unanswered question. Why does Hyperion look and behave this way? What could possibly explain all of these unusual traits happening together in a single small moon, unlike anything else found orbiting Saturn or any other planet? To answer this, scientists have developed several theories over the years. Some ideas have been mostly ruled out through further study, while others remain active areas of research and debate. But among all these theories, one stands out as the leading explanation, a theory that is both fascinating and, in some ways, a little unsettling to imagine. This is the theory that Hyperion may not be a complete original moon at all. Instead, it may be a broken fragment, a surviving piece of a much larger object that once existed peacefully in orbit around Saturn, until something catastrophic happened. According to this theory, billions of years ago there may have been a much larger moon orbiting Saturn, a moon significantly bigger than the Hyperion we see today. At some point in the distant past, this larger moon may have collided with another massive object, perhaps a large asteroid, another moon, or some other significant body moving through the Saturn system. The impact would have been massive, violent, and powerful enough to shatter much of the moon's original structure. Instead of being completely destroyed and scattered into countless tiny pieces, though, scientists believe that at least one significant chunk of this ancient moon may have survived the collision, held together loosely by its own weak gravity. Over time, this surviving fragment would have continued orbiting Saturn, slowly settling into the object we now know as Hyperion. This theory helps explain many of Hyperion's strangest features all at once. If Hyperion truly is the broken remains of a larger moon, this would explain why its shape is so irregular and elongated rather than smooth and round like moons that formed normally. A moon shattered apart by a massive impact would naturally end up looking exactly like what we see, fragmented, uneven, and lumpy, rather than perfectly spherical. This theory also helps explain Hyperion's unusually low density and porous, sponge-like internal structure. If Hyperion formed not through the slow, steady buildup of material over millions of years, but instead through the sudden, violent breakup of a larger object, it could easily explain why so much empty space exists throughout its structure today. Rather than being tightly compressed by gravity over a long, gradual formation process, a shattered fragment held together loosely after a violent collision could naturally contain large internal gaps, cracks, and empty spaces, exactly the kind of structure scientists observe when studying Hyperion's density. And finally, the same violent origin story helps explain Hyperion's chaotic, unpredictable rotation. A moon that formed normally, gradually, and symmetrically would likely settle into a steady, predictable spin over time, the same way most moons eventually do. But a moon that began its existence as an irregular, unevenly shaped fragment from a catastrophic impact would be far more likely to experience exactly the kind of unstable, chaotic tumbling that scientists observe in Hyperion today. Taken together, the single dramatic theory, a moon shattered by an ancient impact, offers a surprisingly complete explanation for nearly every strange feature we have discussed throughout the story. The irregular shape, the sponge-like craters, the low density, and the chaotic rotation. But if this theory is true, it raises an even bigger and more exciting question. If Hyperion truly is just one surviving fragment of a much larger ancient moon, what happened to the rest of it? Some scientists believe that if such a violent collision really did occur, there could be other fragments from the same ancient moon still scattered throughout the Saturn system today, quietly orbiting the planet, largely unnoticed and unexplored. These fragments, if they exist, could be hidden among the countless smaller objects and debris already known to orbit within Saturn's extensive system of rings and moons. This possibility excites many scientists, because if additional fragments were ever discovered and confirmed to share a common origin with Hyperion, it would provide direct physical evidence supporting this dramatic collision theory, potentially transforming it from a leading theory into a confirmed chapter of Saturn's ancient history. However, it's important to understand that despite how compelling this theory is, it still remains unconfirmed. Scientists have not yet found direct proof of this ancient collision, nor have they conclusively identified other surviving fragments definitively linked to Hyperion's origin. Much of what we understand today comes from indirect evidence. Hyperion's shape, its density, its chaotic rotation, and comparisons to similar impact events observed elsewhere in our solar system. There is also another layer of mystery that continues to intrigue scientists: the internal structure of Hyperion itself. While scientists have calculated that Hyperion likely contains a significant empty space internally, based on its low overall density, they still do not fully understand exactly how this internal structure is arranged. Is Hyperion filled with countless tiny voids and cracks scattered evenly throughout its interior? Or could there be larger, more significant internal caverns and hollow spaces hidden deep within it, areas we have not been able to detect or study directly? Currently, no spacecraft has ever landed on Hyperion's surface. Every piece of information we have gathered so far comes from spacecraft flying past at a distance, using cameras, radar, and other instruments to study Hyperion from orbit or during brief flybys. While these missions have given us incredible insight into Hyperion's surface appearance, density, and rotational behavior, they have not been able to directly explore what truly lies beneath its cratered, sponge-like exterior. This leaves open one of the most exciting possibilities in the story of Hyperion: the idea that future missions, perhaps involving landers or even more advanced robotic probes, could one day land directly on Hyperion's surface, drilling beneath its outer layers or using advanced imaging technology to finally reveal what lies hidden inside this strange, mysterious moon. Until that day comes, Hyperion remains one of the most intriguing unsolved mysteries in our solar system. It continues its slow, chaotic tumble around Saturn, exactly as it has done for billions of years, its true origin and internal structure still hidden from us, waiting patiently for the day when human curiosity and technology finally catch up enough to unlock its remaining secrets. So, what do you think really happened to Hyperion? Was it truly shattered by a massive ancient collision, leaving behind fragments still hidden somewhere in Saturn's rings today? Or could there be an entirely different explanation, something scientists haven't even considered yet, waiting to be discovered? Share your thoughts and theories in the comments below. And if you enjoyed uncovering this incredible space mystery with us today, make sure you are subscribed to this channel, because every week we explore another strange and fascinating mystery hidden throughout our solar system and beyond. Turn on notifications so you never miss the next journey into the unknown. Until next time, keep looking up, because the universe is still full of mysteries waiting to be solved.